I'm sorry you're sitting in a no yawning zone over there, invisible woman. All right. For those of you who are watching this, you're probably wondering why I said that. There's no point. Right now we are chapter 7-7, dealing with radical equations and inequalities. We've already started this problem, so you're running a little bit behind. You might need to pause me and write down isolate the radical by adding a 2 to both sides. We had to do on problem 2. Okay. Now that you have the radical isolated over on the left-hand side right here, there is the radical right there. That's called a radical sign. All right. Then you have one option. One option is from right here, you could take this side and this side, and you could square it if you wanted to. That's one option. So we're going to do it that way starting out, letting you know that's okay. You can do that. Now, something you need to be aware of. Okay. Step number 2. What did we do to both sides? We squared both sides. Now, just remember, if I have a radical x and I square a radical x, that's just x. If I had a radical x, y, z, and I squared a radical x, y, z, that would become x, y, z. If I squared a radical stoic face, what's that going to become? Stoic face, right there. It's not going to become happy face, it's just going to be stoic face. All right? If I made it angry face, then I'd have to draw those little angry eyebrows. Okay? So whatever you have inside of a radical, if you square it, it is whatever it is inside the radical. So what am I allowed to bring down in this radical? What is the square root of 3h squared? That's just going to be 3h. But what do I have to do with the 4? I also have to square the 4. So this is going to be 16 times 3h equals, and what is 2 squared going to equal? 4. So you got to be careful. If you start by squaring both sides, because you have the radical isolated, you can't forget to square the number that's on the outside of the radical. Let's go there, Blue. All right, so right now, Blue, we're doing problem number 2. Get your journal out, write down everything we're doing. All right, changing colors now. From here, we have a couple of options. If you wanted to, you could divide both sides by 16, but I'm not going to. Because if you wanted to, you could multiply both sides, not both sides, you could multiply the 16 times 3 and get what? Get 48h equals 4. So step number 3, in this particular way, what did I multiply? Multiply 16 and 3h to get 48h. And the very last step is to do what to both sides? Divide both sides by 48. And h is equal to 4 over 48, which also reduces to a 1/12. Okay? Whenever you get an answer, make sure you take that answer and plug it back into the original equation to see if it works. Okay? Now, we divided both sides by 48. What could you have also done? If you wanted to, you could have multiplied both sides by 1 over 48, known as its inverse. So you could have also done that. And you would have gotten the same answer. Now, let's go over to our calculator real quick. Look at our problem. Right here. Going to type in, check this out, a 4 radical 3 times, and what was our final answer? 1/12. So plugging in 1/12 for the h. And what did we take away? We took away what? minus 2. And what should this equal? 0. And does it equal 0? It does, therefore you got the right answer. Now I told you right here at the very beginning, I said we're not going to do this one way, we're going to do it 2 different ways. So by the way, here's how I would like you guys to start the second way that you could do it. The first step is the same, we just what? Add 2 to both sides. Okay? So that's the very first step. So step 1 was add 2 to both sides. From here, this is the first step from here. Divide both sides by 4. So if we divide both sides by 4 at the very, very, very beginning, these 4's cancel out. And what are we left with? We're left with a radical 3h equals 2/4, which is a what? 1 over 2. That's one way. You could have also started it by dividing both sides by 4 after you first added the 2 to both sides. At this point, the step 2 is to do what to both sides? We have to do what? Square both sides. We're going to take this side and square it. And do this side and square it. Bless you. Now, a half times a half, right? A half times another half is simply 1/4. So right here on the right-hand side, you have a 1 over 4. The square root of 3h squared is 3h. Now this time, I'm actually, instead of saying divide by 3, I'm going to say multiply both sides by 1/3. I want you guys to know that sometimes it's in your benefit to multiply it by its inverse. You could multiply everything by its inverse all the time. But I know a lot of you like dividing both sides by that number. Okay? But multiplying by the inverse means I'm going to take this side and multiply it by 1/3, and this side and multiply it by 1/3. Well, what is a third of 3? Third of 3 is 1. And what is 1/4 times 1/3? Top times top is 1. Denominator times denominator is 12. You get the exact same answer. I realize some of you will gravitate towards the first process because you don't have to worry about multiplying both sides by the inverse. Some of you may be okay with this process too. All right. The next example problem I'm going to skip all the way down to. I'm going to skip down to problem number 8. Okay. Here's problem number 8. We're going to work through it from beginning to end, and this time we're actually using the concept of rational exponents instead of the concept of radicals. Step number 1. What are we going to do to both sides? Right, we're going to subtract 2 from both sides. That's the first step. Here's what we have. In parentheses, we have 6u minus 5 raised to the power of 1/3 equals a negative 5. First step. Now, I am not going to make you change this to a radical. Okay? I want you guys right now to realize that this right here, this guy right here is raised to the power of 1. So raise that to the power of 1. What is the inverse of 1 over 3? 3 over 1. So what I'm going to do is I'm going to apply the power of 3 over 1 to this side of the equal sign, and I'm going to apply the exact same power of 3 over 1 to the right side of the equal sign. going to happen to these? These are going to cancel out and make it just a 1. So here's what we have left. We have a 6u minus 5, now just to the power of 1, equals negative 5 raised to the power of, what's 3 over 1 times 1? 3. What is negative 5 times negative 5 times negative 5? Negative 1.1. So put negative 125 right there. We have 6u minus 5. At this point, we've just changed the problem to really, now it just looks like an Algebra 1 problem now. All we got to do what? To solve for u is do what? Add 5 to both sides. We have 6u equals negative 120. Divide each side by 6 or multiply both sides by 1/6. And what is u equal to? Negative 20. What I want us to do now is I want us to check our answer. I want us to take this answer right here and let's check it to see if it actually works. Does everybody see our problem right here? Okay? So go to the calculator. I'm going to clear this out. I'm going to open up a parentheses. I'm going to type in 6. What am I going to plug in for my value for u? Negative 20. Close the parentheses. Minus a 5. Raise that to the power of what? 1/3. Hit the right arrow. What did we do after that? We add or subtract? What's the plus 2? And press enter, and what should it equal? Negative 3. And does it equal negative 3? It does. Therefore, you got the correct answer. So what was the first way? The first way we used radicals. The second way we actually used the power of exponents.